Yeah. Yep. Chalo, others, cams on. Where are the rest? Okay. So last thing we are doing was this areas and volumes. So today we'll be doing a little different thing, calculus based on kinematics, especially. First, let's see some general formulas and then we'll go ahead. That's it. We know velocity is given by rate of change of position. R bar is position vector. Let me show you this thing, then we'll go ahead. Integration of a vector. How do you integrate a vector? The same way we did for differentiation, there is no difference. So if you have a vector a bar, which is ax I cap, ay j cap, az k cap, and if someone asks you to integrate the vector a dx or dt, let's say, this would be ax dt I cap plus integral. So each component you just integrated. If you remember, the same thing we did in differentiation also. We just differentiated each component without actually affecting it. So that's how you integrate a vector. Have a look at this. Hope everyone saw that extra sheets which I sent you. I sent you a sheet on calculus. All clear with this? Now, example, let's say if A is equal to T I cap plus T square J cap plus T cube K cap. And if someone asks you to find integral A dt, so this is as good as integral T dt I cap plus integral T square dt J cap plus integral T cube dt K cap. Yeah, whatever are the limits. Limits I have not given here. So T square by 2 I cap, T cube by 3 J cap, T power 4 by 4 K cap. plus constant, basically, since limits are not given. If limits are not given, always have to add plus constant. It's indefinite integration.
Sir, that the sheet you had sent on basic calculus was the same sheet, right? Which was there in the earlier.
Come again. The sheet got repeated again?
Yes.
Okay. Okay. But there's nothing new in that. Everything was repeated.
Actually, that entire sheet was a part of the first sheet.
Okay. The first sheet you got only part of it, na? Okay, na?
The entire sheet was a part of that one.
Uh,
The first sheet actually had 2 sheets in it.
Okay. So things got mixed up. So fine, not an issue. All clear with this? Now, let me show you one question how to do this, and then I'll give you more. So we know velocity. This is a definition of velocity actually. Velocity v bar is the rate of change of position vector. We'll wrap up calculus today. Next class we'll start off with kinematics. Where's the reach in pace right now?
That kinematics story now.
Projectile motion they're doing?
Yes.
When is the holidays they're planning to give? When is the major test?
The 3rd July to 17th July, the holiday.
To 17.
Yeah.
16.
And major test is on 29th and 30th of July.
Okay. So 3rd to 16th, they're given 2 weeks break. Big break. So acceleration is dv by dt. This can be also written as this term becomes v. So acceleration also becomes v dv by dr. This is actually v subscript x dvx by dx I cap. Subscript x meaning velocity in the x direction. So vx implies velocity in x direction or component of velocity in x direction. So if you differentiate that, you get acceleration in x direction. I'll write it here. Vx is component of velocity in x. Vy dvy by dy j cap vz dvz by dz k cap. So this can be also written as ax I cap, ay j cap, and az k cap. So this ax is the component of acceleration in x direction. So an acceleration is a vector, it can have 3 directions. So Have a look at this. So for acceleration, there are two formulas. A is equal to dv by dt. A is equal to v dv by dx. So basically use this if A is given in terms of time. Use this if V is given in terms of position. Have a look at this. Ask me if you're confused anywhere.
Sir, could you repeat again? I just joined.
This is the thing. There's nothing that we wrote. Velocity is dr by dt, acceleration dv by dt. And please be on time. It won't be possible to repeat.
Okay, sir.
You guys missed the starting introduction. The whole rest of the class will be weird. So these things you know now, Mayuka. Velocity is dr by dt. Acceleration is dv by dt. Or it can be written as velocity into dv by dr, which can be written as three components: vx, vx, dv by dx, this thing, and this thing.
Yes, sir.
All clear? So let me give an example how to solve, and then I'll give you more varieties. Turning the page.
Sir, just a second.
Yeah.
Done, sir.
So example, let's say we have a constant acceleration. So we have acceleration A is equal to constant. So from here, we need to find velocity and positions. Okay. So listen how we do this integration. It is an easy one, but this is the basis of what you're going to do for the full day today. So we have acceleration A is equal to some constant. We know A is equal to dv by dt. So I can write this thing as dv is equal to acceleration into dt. So you can just shift dt that side. Integrate both sides. So here let's define some variables. U is your initial velocity. That means velocity at time t is 0. Whenever someone says initial, meaning he's saying time is 0. X naught is your initial position. So when you integrate on both sides, listen carefully. Write later. dv is equal to integral a dt. Now you kept the integral. Now you have to put the limits. Now what are the limits of meaning here? When time is 0, this is the meaning of the limits. When time is 0, the velocity is u. So don't put 0 to t and 0 to v. The limits are actually telling you how is the situation happening. When the time is t, velocity is v. So v is the velocity at time t. So this dv is nothing but v power 1 ka integration. So v limits will go from u to v. A is a constant that comes out of the integral. You'll get t. Limits will go from 0 to t. So this will be v minus u is equal to a into t minus 0. We get v is equal to u plus at. This is your first equation of dynamics. This, if I integrate it further, v can be written as dx by dt. which is u plus at. Send dt that side. So dx will be u into dt plus a into t dt. Integrate again. Dx, this will be u is constant, integral dt. A is constant, integral t dt. Again, when time is 0, your x is x naught. That's the meaning of limits. So on the right hand side, when you say 0 to time, so at t0, what is your x? Your x is not 0. It is some x naught, which is given x at time t. So this would be x integral. This will be from x naught to x. This will be u into t, limits 0 to t, plus a into t square by 2, limits 0 to t. If you substitute this, you end up with x minus x naught is equal to u into time plus half a t square. X minus x naught is nothing but displacement. So we write this thing as s is equal to ut plus half a t square. This was your second equation of kinematics. This is how we can actually derive them. Have a look at this, how we did this.
Sir, can you explain the x naught part again?
X naught is the initial position. So when time is 0, your x coordinate is x naught. Right? That is the meaning now when you say time limits 0 to t, meaning when time is 0, what is your x? X naught.
Yes, I understood.
That way. Please have a look at this. Anyone confused how I did this? Any step you're confused, please ask. Clear? I'll write S as displacement in the next page. But please look at the steps how I did that. So basically I integrated here 2 times. First, when I integrated with time, A became, I got a relation between V and time. Again, I integrated, I got position and time. Clear? Can I turn the page? So here basically S is nothing but displacement, which is nothing but your final coordinate minus initial coordinate. In this case, I took initial coordinate as x naught. So there's another way to write this. We know acceleration is v dv by dx. I'm putting in one dimension only. So this will be v dv is equal to a into dx. Integrate on both sides. Initially, the coordinate is x initial. Let's say this is x final. Maybe that will give it better. So this is u to v. This will be v square by 2. Limits will go from u to v. A will come out. This will become x initial to x final. This will go to v square minus u square by 2 is equal to a into x final minus x initial. So this is v square minus u square is 2 into a into x final minus x initial, which is nothing but v square minus u square is 2as. This is your third equation. So this is how you got those 3 kinematics equations which you studied in school. V is u plus at, s is ut plus half at square, and v square minus u square is 2s. The only condition is a should be constant. Because a was constant, every time it is coming out of the integration, no? If that a was not constant, you can't do this. So if a is variable, what to do? No, that's what you're going to see next. So if someone gives you a as a function of something, this is how you find velocity and position as function of time t. Quite a useful concept. Next chapter which you're doing kinematics, you will repeatedly use this. So basically the cycle, right, goes like this. If you have a position, you want velocity, then differentiate. You want acceleration, again differentiate. So if someone gives you position and asks you velocity, differentiate. If someone gives you acceleration and asks you velocity, then integrate. So you need to understand where are you in the cycle. Integrate. So if someone gives you acceleration, you have to do integration to get position. If someone gives you position, you have to differentiate to get acceleration. If someone gives you velocity, you have to differentiate for acceleration, integrate for position. Is that making sense? All clear with this? Let's see a question. Can I turn the page? Let's say acceleration of a body A is given equal to t. T is time. Initial velocity is 3 meters per second. Initial position x is equal to -2 meters. Find velocity as function of time t, v of t, and position as function of time t. Let's get them. So now the a won't come out of the integral. You have to do what we did before, but there a is not constant now. So you can't use the 3 regular formulas which we derived. Any answers? Let's see. Acceleration will be dv by dt, and you're saying this is equal to time. So dv is equal to t into dt. Integrate. So integral dv is equal to integral t dt. So when time is 0, velocity is 3 actually. It is given. The initial conditions are given. Be careful. Don't put 0 there. He said initial velocity is 3, meaning when t is 0, the velocity is 3. When time is t, velocity is v. So this will be v. Limits will go from 3 to v. This guy is t square by 2. Limits will go from 0 to t. So this will be v minus 3 is equal to t square by 2. So we get v is equal to 3 plus t square by 2. That's your velocity as function of time, people. Then again integrate this. V is dx by dt, which is 3 plus t square by 2. So dx will be 3 dt plus t square dt by 2. Integrate again. So this will be 3 will come out constant. Half will come out. Integral t square dt. Time is 0. Position is minus 2. It is given. When time is t, it is x. So basically, after time t, we don't know where it is, right? So let that be x. After time t, we don't know the velocity. Let that be some v. And this guy is t. So this limits will be x will go from minus 2 to x, and this guy will be 3 t. Limits will go from 0 to t. Plus this will be half into t cube by 3. Limits will go from 0 to t. This will be x minus of minus 2. That will become x plus 2 minus of minus 2. This will be 3t plus t cube by 6. So x is equal to 2 plus 3t plus t cube by 6. Please check your answers.
Now what did he minus 2?
By
X minus minus 2 plus 2. We will take it that way.
so minus the I side. You're right. Please check. I think some of you didn't keep the limits. Or you just left it in terms of u or something. All clear with this? Next one. Can I turn the page? Let's see one more like this. Velocity v is given by t cube by 3 plus t. Initial position x is equal to plus 3. Find position as function of time t and acceleration as function of time t. Let's try this. Get this, just get this. I'll just get some water and come. Let's see. A is t square. A is easy. So for acceleration, you just need to differentiate. So that would be t square plus 1. Get the position. Get it, I'll give you a minute. For that, you have to integrate. So that's what I was saying. If I give you b, you need to know whether should I differentiate or integrate. X will be brute force integration. There's nothing there to think in this. Just put the integration and finish it off. See, so velocity will be dx by dt is equal to t cube by 3 plus t. So dx will be t cube dt by 3 plus t dt. Integrate this. Limits will go from 0 to time. 0 to time, x will go from 3 to x. So this will be x minus 3 is equal to t power 4 by 12. And this guy is t square by 2. Please check your answers. Easy? Next one. Next one. Acceleration is equal to minus, let's say, 2x square. At x is equal to 1, v is equal to 2. Find velocity as function of x.
So can you go back for a minute? Yes, yes, thank you. How to do? Now I can write a as dv by dt, but the problem is then you have 3 variables. V, time, position, you can't do anything. So you need to write a as v dv by dx. Yeah, you get something like that. Let's see. So this will be v dv is equal to minus 2x square dx. So integrate this. Here when x is equal to 1, v is equal to 2. That is the meaning of the lower limits, people. So when x is equal to 1, v is equal to 2. When x is some x, velocity is some v. So v square by 2, limits will go from 2 to v, will be equal to minus 2 x cubed by 3, limits will go from 1 to x. So this will be v square minus 2 square by 2. This is minus 2 by 3 x cube minus 1 cube. So v square will be 4 minus 4 by 3 into x cube minus 1. So v will be root over. You can simplify this further. How much is that? 4 minus 4 plus 4 by 3. So that is 16 by 3 minus 4 x cube by 3. That's your answer. Check. Marian got the same thing. You forgot the limits, I guess. Please check the limits. Most common mistake is people forget the limits. Any doubts on this? All clear with this? Turn in the page. Let's say A is equal to minus KB. K is some constant. Initial velocity, U. Initial position, x naught. Find v of t and x of t, velocity as function of time t and position as function of time t. How do you do this? This is a good one, right? I hope you remember this integral dx by x na is ln x. Did they teach you logs in class? They didn't teach you logarithms yet. Okay, then I think thoda difficult hoga. Try for a minute, I'll show you. Velocity फिर भी आना चाहिए. I'll just tell you, explain a little. Listen. Actually, what is this log ka concept, right? What happens in certain chapters, right? You will observe certain quantities have very huge values. The best example, if you look at your pH scale, ever heard about this? Acid ka pH scale. The pH scale ka concentrations, right, are like 10 power minus 1, 10 power minus 2, 10 power minus 3, and so on like this. So the numbers look like, these are very huge numbers actually. If I try to plot this on a graph, what will I see? Let's keep it simple. If I say 10 power 1, 10 square, 10 cube, if I try to plot this graph, let's say if I say this is 10 power 1, where is 10 square? It is 10 times of this line, right? Where is 10 cube? It is 10 times of this line, right? You're getting it? You won't be able to plot it on a graph. So people said, yeah, this is becoming too cumbersome. So this came up with this technique of logs. So if you have a quantity a to the power of b is equal to c. So this what they do when you apply log on both sides, this will become log b is equal to let's write lever c is equal to a power b. So this will become log c is equal to log this will be log c to the base a is equal to b. So what they did, right? They just shifted this a to the base. So we call this thing base. Basically, b is the power. So meaning of this example, so if someone writes log, x by 10 is equal to 6, the meaning of this? He's saying x ka value is 10 to the power of 6. So the 10 is the base and 6 is the power. So 10 is your base and 6 is your exponent or power, whatever you want to call. So you can just shift this side. So this will become x is equal to 10 to the power of 6. So now see what will happen. Your life becomes so easy to draw the graph. If you have 10 power 1, 10 square, 10 cube, if I ask you to draw the log graph, you will just draw as 1, 2, and 3. Na? So when you say log graph is 3, I understood it is 10 to the power of 3. When you say log graph is 2, means I understood it is 10 to the power of 2. So indirectly, you're giving the powers. Clear? That is the main idea there. Let maths people teach you more. So the one concept I want you to know is this thing. If you have something like log x to the base a is equal to b, you can simply shift a that side, it will become x is equal to a power b. That is one thing you should know. If you have ln a plus ln b, this can be written as ln ab multiply. Ln a minus ln b can be written as ln a by b. If you have ln something like a to the power of n comes out, it will become ln a. The same thing, ln is actually natural logarithm, but he can. These are some other things which you should know. This is a pretty good one actually. Question is a good one. Let's see. I'll show you. So listen how to do this thing. It's more of a log. Maybe we are stuck here actually. So acceleration is dv by dt is equal to minus kv. So dv by v is equal to minus k into dt. Integrate on both sides. dv by v is equal to k is constant into dt. When time is 0, your velocity is u. When time is t, your velocity is v. dv by v integration is ln v. In case you forgot, you can go back and check the formula. dx by ax plus b ka integration was 1 by a ln ax plus b. So in our scenario here, a is equal to 1 and b is equal to 0. Limits u to v is equal to minus k time limits from 0 to time. So this will be ln v minus, then put ln u is equal to minus kt. Ln a minus ln b is ln v by u. So when you say ln, right, actually the ln ka base is e. So when you say something like ln a, people don't mention it. The meaning is actually it is a base e. That is something new which you guys don't know. E is what? The exponential number 2.713, just like pi. So v by u is equal to e power minus kt. So we get velocity is equal to u into e power minus kt. Slightly confusing, right? I'll see if I can get you something on log, I'll send you. But this much only we need to know that, ln a minus ln b is ln a by b. And if you have log x to the base b, you can just shift it there. So if someone writes like log a, log matlab log to the base 10 to the a. So base is 10. If someone writes ln a, means it is a base is e. That's a convention. If someone just uses ln, matlab base is e. If someone uses log log, so its base is 10. Have a look at it here. This is the thing. Don't worry about it. Once I teach you the logs, this will be quite easy. Then I'll show you again. We will do it multiple times. It will come later on. I think from here you can do. You can find position from here though. So this is how you get velocity as function of time. For now, I think you should mug up. You can expect this in the exams. Because exponentials are one functions, right? Like which are pretty common in physics. You encounter them a lot. From here, can you find the position? Yeah, close by, Aryan. You forgot something there. U into power, let's see. So we got V is equal to U into e power minus kt. This can be written as dx by dt is equal to U into e power minus kt. So d will be e power minus kt into dt. Integrate this on both sides. I hope you remember e power ax integration. When time is 0, x is x naught to x, and this is t. So this will be x to x naught. U, for people who forgot, e power ax dx का integral was 1 by a e power ax. So here a का place में we have minus k. So minus 1 by k e power minus kt integral from 0 to t. The other goof of people do na, e power 0 is not 0. This is x minus thing minus u by k. Substitute time, you get e power minus kt. Substitute 0, you get e power 0. So e power 0 is not 0. So we get x minus x naught is equal to u by k, e power 0 is 1 minus e power minus kt. So we get x is equal to x naught plus u by k, 1 power minus kt. Check. That's your mistake, Radian. You forgot, I think you kept e power 0 as 0. Adil, you forgot your initial x naught. Please check everyone. Once you got the velocity, this fine.
S, the displacement.
Oh, तो s निकाल दिया क्या? चलेगा. Then it is right. Have a look at this. That log part, you just need to wait for them to teach. It's a small chapter. But log this much only I need. These things. Clear with this? Any doubts on this? Next one.
Sir, can you go to the page before this for a minute? Yes, sir. Thank you.
Turn in the page. Let me show you another type of question. Let's say we have a resistor. R is 10 ohms. Charge Q is flowing through it. So Q is equal to T cube by 3 minus T square by 2. Q is charge. Current I is given by dq by dt. The heat produced in a resistor. Remember power in a resistor ka formula I square R. So heat produced in a resistor is given by integral I square R dt. That is the formula for heat produced. Don't worry how we got it. The question is find heat produced in first 2 seconds. So someone gave you a charge flowing in the resistor. Q is the charge flowing through the resistor. But that is actually useless. What you're interested in is actually current. I square R dt ka integration is actually heat produced. So from charge, you need to get current and then use that current and integrate and get the heat produced. Get this. Twenty by 3. First thing you need to find the current. So I is dq by dt. So just differentiate that guy, which will be t square minus t. Then what is heat? I square R dt. So t square minus t ka whole square. R is 10 into dt. Limits are from 0 to 2 seconds because it's a heat produced in 2 seconds. So now you have to integrate this. Let me do it on the next page. So if I expand that thing, t square minus t whole square, 10 will come out, dt from 0 to 2. This will be t power 4 minus 2t cube plus t square dt will go from 0 to 2. So this will be t power 5 by 5 minus 2t power 4 by 4 plus t cube by 3. Limits are from 0 to 2. So if you put 2 there, you get 32 by 5 minus 2 into 2 power 4 is 16 by 4 plus 8 by 3. 0 is anyway not required. Forza. Numbers are bad. 32 by 5. That's almost 6.4 minus 8 plus 8 by 3. Eight by 3 minus 1.6. 4.88 to 3.2. 32 by 3 joules of heat. Check. Adrit, you got 20 by 3. Swastika, you got 80 by 9. Please check. I goofed up or you guys got it wrong. Some of us is wrong. Please look at the steps. So first what you do, differentiate. Get the current t square minus t. T cube ka differential is 3t square. 3 cancel hoga. T square differential is 2t. The most common mistake na, there is a chance you might mix up integration and differentiation ka formulas. Just be careful there. So in case of integration, you do differentiation, differential calculation, integration, that mistakes happen. Once you got that, if you see brute force, there's nothing there to think. In today's class, it is like you got the formulas, put it there, solve, solve, solve.
So in the integration part, we could have also done VIT, right? VI delta T.
But you don't know V, right?
How we can calculate that now after we get the current.
You can do that. But same aayega. It doesn't
Same,
matter.
exactly. It'll be the same.
Have a look at this, everyone. Yeah, next one. Any doubts on this? So there, you can ask questions like this also. It doesn't mean every time you'll get in terms of equations there. Velocity and this thing, you can get in top many multiple places. Next one. Acceleration is t square I cap plus 1 by t square j cap. At t0, v is 0. Find time when acceleration is perpendicular to velocity. Now vectors are given. How do you integrate a vector? Just integrate t square and just keep I cap outside, 1 by t square j cap outside. So you can just integrate them as if I cap, j cap are two different things and just add them up in the end. Acceleration is given. Find the time when the velocity and acceleration are perpendicular. Try, everyone should give it a try. Let's see. 8 through 3. Okay. So now how to do? Just have to be careful. It is same thing. So acceleration was dv bar by dt. So you just keep putting bar everywhere on the top now. T square I cap plus 1 by t square j cap. So dv bar will be t square dt I cap plus 1 by t square dt j cap. Now when you integrate this will be integral dv bar. Now here the velocity initially is 0. So yeah, 0 to v. And this will be t square dt ka integral I cap plus dt by t square j cap. Limits will go from 0 to t. I goofed up, I guess. I goofed up. How did you guys get this? We goofed up actually, because when you put 0 to t here, यहाँ पे integration 1 by t आएगा, t becomes undefined. Isn't it? We goofed up there. But anyways, I'll just show you what is a goof up in case you didn't understand. So this will be v on the right hand side. This will be t cube by 3 I cap. There is no problem there. This guy is minus, limits will go from 0 to t, plus this will be minus 1 by t j cap. Limits will go from 0 to t. अभी देखो ये goof up था actually. So this will be t cube by 3. There is no problem. This would be 1 by t minus 1 by 0 j cap. This is gone, na? Understood what we did? That was a mistake actually. This is undefined. And if you ignore that and solve, if you ignore that, which we can't, which is a mistake, then what to do after that? A bar dot v bar is 0, isn't it? So basically we can't solve this. Question is wrong. Are you getting the thing? So somehow if that was not 0, meaning let's say limits are 1 to t, then ye 1 aega, then it is not bad. Then you just need to do the dot product and equate it to 0, you would have got the answer. So be careful, just don't put it directly, that is 1 by 0 there. It's a mess. Because what happens, right? You are so habituated to writing, na? T is t, 0, so you forget about the second term, and the second term can goof up. Question is wrong. But I hope all got the idea how to do this. Pull it off. Let me show you one more like this with vectors. All clear with this? Hope you got the mistake what I did. Let's say acceleration is sine 2 times time I cap plus cos 2 times time j cap. At t0, v is 0 and x is 0. Find velocity as function of time t, position as function of time t. Let's get this. This is a good one. Sine 2t I cap, cos 2t j cap. Acceleration is given. Find velocity. Vector as function of time t, position as function of, I should write this is r bar actually. Try. 2 minutes, everyone. See your sine 2 minus nahin, Adrit. Again, I think you're messing up that, limits. You guys are messing up the limits. When you keep limit 0 to t, sine 0 0 tha, but cos 0 0 nahi hai. You're getting it? That limits mein you're messing up. Both of you, Adrit, Aryan, check karo. When you keep the limit sine 2t 0 to t, problem nahi hai. Cos 2t 0 to t, that cos 0 is 1 actually. Let me show you that. So acceleration is dv. I'm skipping the steps now. So this will be sine 2t dt I cap plus cos 2t dt j cap integral 0 to v, 0 to time and 0 to time. Hope you remember sine ka integration. Sine ax ka integral is minus 1 by a cos ax. In case you forgot, you should definitely go and mug it up. Cos ax ka integral is 1 by a sine ax. So this will give you v on the left hand side. So sine 2t will be minus 1 by 2 cos 2t. Limits will go from 0 to t I cap plus cos 2t will be half sine 2t. Limits will go from 0 to t j cap. So minus half, when you substitute the values here, you get cos 2t minus cos 0 I cap plus half. When you put the values here, sine 2t minus sine 0 j cap. So this thing turns out to be half into cos 0 is 1, 1 minus cos 2t I cap plus half into sine 2t j cap. Be careful. This one is the thing which people miss. Have a look at that. That limits part, people go from 0 to t. When you put 0, you always won't get 0. That was a mistake we did in the previous problem also. Anyone confused here? Please ask. Please check. Anyone confused with any particular step you didn't get? Ask me. Now you still have to find position. Huh? Try. Abhi question hua nahi. Now you got velocity. Now you have to integrate this again to get position. Try. Now that will, you will understand now again 0 to t limits. Anyone confused? Anyone didn't get this thing? Please ask. Mehan, keep your cams on. Aryan, so far everything clear? Niranjan? Swastika? Clear, no? Abhinav? Venkatesh? Great. Maulika?
Yeah.
Clear. Arjun? Got this thing?
Yes, sir.
Perfect. Try everyone. So we got velocity is half into 1 minus cos 2t I cap plus half into sine 2t j cap. So let this be dr by dt. Don't write dx by dt, yeah? Because it's a vector now. Dr by dt. So what you get is a position vector. I'll just take out half outside. Send dt that side. This will be dt minus cos 2 dt. Integral, this whole setup is I cap. Again, don't forget 0 to t and 0 to t plus integral sine 2t dt ka j cap. So this will give out to be r bar. This will be half into the whole thing dt, that will be t only, limit 0 to t. Cos 2t ka integration is half sine 2t limits 0 to t I cap plus this guy will be again minus half cos 2t 0 to t j cap again half. When you get a cos now, cos 0 is not 0 there. So this guy will turn out to be half overall t minus half sine 2t I cap minus half, that would be cos 2t minus cos 0 j cap. So the final answer r bar will be half t minus half sine 2t I cap plus half into half is 1 by 4, 1 minus cos 2t j cap. That's your final answer. Check. Most common mistake is that when you put 0, cos 0 won't become 0. Please check. E power 0 is not 0, cos 0 is not 0. Anyone confused? Any part you're not clear, please ask. It's just brute force integration, there's nothing there. Clear? Go ahead. The next one is a good one. Comes in 3 chapters. Turn the page. We know the work done by a force. The formula is given by f bar dot dr bar. So integration dot product. Vectors, everything is there, and this is the formula there for work done. Okay, so let me show you an example. So let's say the question is like this. If the force vector is x into I cap plus y into j cap, meaning this force is a pretty variable force. Matlab, as x coordinate is changing at different points, you have different forces. If you're at 1, 1, force is I plus j. If you're at 2, 3, force is 2i plus 3j. So the force is changing with x and y. Right, and let's say force is equal to x square. So let me show you for one, and then I'll give you more. So how to do this kind of question? So the question is find work done by the force when it goes from point A, which is let's say 1, 1, to point B, which is 2, 3. Okay, this is the question. So let's see how to do this. The first thing, r bar is a position vector, which is nothing but xi cap, y j cap plus z k cap. So what is dr bar? So dxi cap, so small dxi cap, small dy j cap, and small dz k cap. Substitute in the formula. The work done is integral force is xi cap plus y j cap
dot dxi cap plus dyj cap plus dz k cap. So we have to do a dot product first. That will give you x into dx because I caps will multiply together. Y into dy, y will multiply together. Z is gone. There's no z here. You're going from where to where? You're going from A to B. So A is initial and B is final. So this should be XA. You're going to initial 1. You're going to final XB is 2. So basically XDX is changing X coordinate. This is Y ka integration. So YA, you're going from A ka Y coordinate, which is 1. You're going Y ka B coordinate to 3. So this integration would be x square by 2. Limits will go from 1 to 2. Remember, it's a scalar quantity. This will be y square by 2. Limits will be from 1 to 3. Substitute. 2 square minus 1 square by 2 plus 3 square minus 1 square by 2. That would be 11 by 2 joules. Look at the process what we did. So this formula, how did we get? This will be given. That don't worry. When we do the chapter, we will see. But for now, you take it from work done is f bar dot dr bar. So matlab isme there's a dot product plus integration. So the question is, if the force is xi cap plus yj cap, find the work done to go from A to B. We will do some simpler variations of this, but more questions on this we'll do in the actual chapter work power energy. Have a look at this. Anyone confused with this, please ask.
I can explain this dot product part again. It was
How to do dot product, right? Remember dot product, how do you do?
the
If two vectors are given dot product, what you do? You multiply the I components, multiply the y component, multiply the z components. Isn't it? That will be x into dx, y into dy. Isn't it? Z is not there here. Z is anyway 0. Sure? Confused?
how will we put the limits here?
You are integrating what here? X dx na? So when you're going from A to B, x kya change ho raha hai? When you're going from A to B, what is x changing here? X is changing from 1 to 2, right? When you're going from A to B, how is y changing? 1 to 3, na? Is that clear? Yeah. That is the meaning of limits, isn't it? Initial to final. We are going from A to B. A is initial, B is final. So A ka initial x coordinate is 1, B ka final x coordinate is 2. The limits will go from 1 to 2 and 1 to 3 for y. Please check. Any other doubt in this?
Sir, I didn't take this dz value at all in either of
Because यहाँ पे z नहीं है ना.
yes, sir. So
If
it's
there's
okay.
a, it is 0 na. Basically, there's no. Basically, this will be like what? Plus 0 k cap. So what is 0 into z?
Yeah, yes, sir.
0. That's why we didn't take. Okay. There is no z component. All got this? Next one. So same question. Let's say if the force is x square I cap plus y j cap, you're going from A 1, 1 to B 2, 3. Same thing. So find work done to go from A to B. I just changed it. I just made it x square plus y j cap. So I'll do one thing. I'll write it here. You can use this as reference and solve. So force is x square I cap plus y j cap. Solve for this.
You just need to make this x square. और कुछ change नहीं था actually. (19/3). Let's see. 19/3. Okay, 2 people got, must be the answer. Yeah. So the idea is the same thing here. The work done will be integral x square I cap plus y j cap. You want, you can write this also 0 k cap, not given, dot. If that z is also given, you would have put z coordinates also. So when you do the dot product, you end up with x square dx plus y dy. So here x ka values are going from xa, which is 1, to xb, which is 2, and you're going from y8 1 to yb is 3. This would be x cubed by 3 by 1 to 2 plus y square by 2 1 to 3. 8 minus 1 by 3 plus 9 minus 1 by 2. 7 by 3 plus 4. 19 by 3. Easy? All got this? This is not the actual question. The next one is an actual question. Can I turn the page? Suppose if the question is this, force is equal to y I cap plus x j cap. So the I component is depending on y coordinate, y component is depending on x coordinate. A is 1, 1, B is 2, 3. We will not change the coordinate, same thing. Find work done from A to B. How will you integrate this guy? This is an interesting concept. Listen, I'll show you one. The problem with this thing, right? When you do this integration, y I cap plus x j cap, you can't integrate it. We have an issue there. Dx I cap, dy j cap plus dz k cap. This will become integral y dx plus x dy. So we can't integrate this because see, y is a variable. Some people will, you can't, it's a, you just can't remove y out of the integral. Both are variables here. So here x and y are variables. You can't remove them out. So listen carefully. So there's a way to do this thing. You can't integrate them separately, but together something happens. If you take y dx plus x dy together, this becomes integral d of xy, product rule. Check, if you differentiate x into y, what do you get? If you differentiate x into y, how do you do? When you differentiate x, keep y outside. When you differentiate x, keep y, keep x outside. Isn't this how you get it? So you can't integrate x, you can't integrate y, but together it will get something d of xy. So that means what you're integrating is a new quantity xy, So here the limits will be, you have to go from xa, ya, which is 1 into 1, to xb, yb, which is 2 into 3. Are you getting the logic? So xy is your new variable. X is not a variable, y is not a variable. We can't integrate. Xy is a new variable. So you're integrating x into y together.
So can you explain this part again? How you got d of xy?
Product rule, na re?
Okay.
If you differentiate, let's say d of f of x, g of x, or let's keep it simple, d of u into v, क्या करेंगे इसको? dxy का differential, how will you differentiate? Y, then
Y d
differentiate
of x plus
x, then dy, na?
Okay.
When you differentiate y, keep x outside. When you differentiate x, keep y outside. Why, na product rule.
Yes.
So this will become x into y. Limits will go from 6 to 1. So this is 6 minus 1 is 5 joules. Have a look at this. These kind of functions are called perfect differentials. This is another way of integrating stuff. You couldn't integrate this and this separately, but together something happens. Put it down. Let me give you one more like this. But any other doubts, please ask.
Sir, can you tell why we got limits as 6 and 1?
Because aapka, what is your new variable now? X into y, na?
Yes.
So initially, what is x into y? 1 into 1. Finally, what is x into y? 2 into 3.
Oh, yes. Got it.
Sure, no? So maybe I should write it here more detail, like 2 into 3, 6. Happy? 1 into
Yes.
1. All got this. Now, using the same logic, I'll give you one more. Let's say if the force is y square I cap plus 2xy j cap. Can you find the work done? This is also perfect differential. We will write that statement. What is a perfect differential? Any ideas? So when you do the work done here, you end up with y square I cap 2xy j cap dot dx I cap plus dy j cap plus dz k cap. This would be y square dx plus 2xy dy. Now you need to actually, figure out this is actually a perfect differential of xy square. So this would be y square into dx plus x into differential of y square. That would be y square into dx plus 2xy dy. Able to see that? Because I'll tell you one thing, in physics now, if you get something like this, either they have to give you a relation between y and x, meaning they'll tell you y is equal to 2x, y is equal to x square. If they give you, then there's no problem. Substitute y and solve. If they don't give you, it's a perfect differential. So in physics, there's no way out. Either you tell me what is the relation between y and x, but if you're not going to tell me, means so perfect differential hoga. So you somehow have to figure out what it is. So this is actually integral d of xy square. Now that is like a puzzle. You need to figure that out, what function it is. You do have ints in this, but yeah. So here, what is the initial value? XA, YA square is initial, which is 1 into 1 square, which is 1. This is XB, YB square, which is 2 into 3 square, that is 18. So XY square comes out, limits will be from 18 to 1. So that is 18 minus 1 is 17 joules. Please check.
So can you repeat what's the perfect differential?
Anything that you can write in the form of like this is called a perfect differential. I'll write in the next page. I'll give you some examples.
Sir,
हाँ,
limits कैसे लिया?
Limits. Now, what is your new term here? The new variable is xy square, right?
XY squared, yes.
So initially, what is xy square?
So initially,
xy square, x is 1, y is 1, 1 into 1
yes.
square, no?
Yes.
Finally, what is xy square? 2 into 3
2
square,
into
no?
3 squared, yes.
So 18, no?
Yes.
Got it? Please check. It's a good one. Clear? So there, that is one. So when you have functions like this now, these are called perfect differential. So what are these perfect differentials? All we can do is give examples. So if you have something like d of xy, so this is x dy plus y dx. So anything that you can converge into a single term. So the two integrals, if you can make it single, it's called a perfect differential. So d of, let's say, x square y, and this guy would be y, or say x square dy plus 2xy dx. It could have been anything, like let's say x by y, x by y. This would be a little more bad. 1 by y dx plus x into minus 1 by y square dy. So on. I can keep giving examples. All got this? What are perfect differentials you're getting? If you can somehow make these two terms into a single term, it's called a perfect differential. All clear with this? There. The last concept we have is integration by substitution. This, I'll just show you one or two examples. Like whenever it comes in physics, now then we can do. That is a better thing, because teaching you now, anyway, you will not remember much. But still, I'll show you some models. But these things are how to do this. We need to by heart them. There is no way out. So integration by substitution. Again, like I'm saying, right, when they actually teach you in maths, all this will look like a joke. Maths, they'll teach you for 3 months. They'll teach you much more dangerous stuff. Meaning, this is like a small puppy. What they teach you in maths is like a Godzilla. I hated integration in maths. It was so painful. So let's see what to do this thing. So in physics, right, few models that we get now. Root over
x square plus a square dx का integral into x dx. This is one form of integral. These are little non-standard ones. In physics, you do encounter such things. You should just know the method how to do these things. A square plus x square dx. So these are some of the standard models. So how to do these things? Integration by substitution. So whenever you get this form, you can put here x square plus a square is equal to t square. If you differentiate on both sides, you get 2x dx. A is anyway 0, constant. This will be 2t dt. I think I'll show you one first. So this will be x dx will be t dt. Substitute in that integration now. So x square plus a square, that will become root t square. X into dx becomes t into dt. This becomes simply t square dt. This becomes t cube by 3 integration. What is t? X square plus a square whole to the power of 3 by 2 by 3. Did you see how we brought this? You converted this integration into a simpler t square dt ka x power n ka integration. Now, how do you know you have to do this? General hint is, if I differentiate this, I'll get x dx. Oh, idea aana chahiye. But like I said, we're not interested in that. So if you get a form like this is the way to do this. Same logic if I apply here, x dx will become t dt, and the denominator a square plus x square will become t square ka root. So this will become simply t dt by root t cancels off integral dt. We get t as an answer. What is t? Root over x square plus a square. So meaning this integration ka answer is this. This method is called integration by substitution. In physics, we have 3 models like this. If you know these 3 models, you'll be able to handle any integration at physics level 11th and 12th. This is the first model. Putting x square plus a square is t square. Is some other variable. So you are converting this whole thing into a new variable and solve it. Have an idea like this, because actually when these questions come now, I'll teach you again. Until unless the max may they do this thing, you will never get that confidence. It's more of a max thing than physics. But do have a look at this, what we did. All got this? Another form. This first form, right, we'll encounter in kinematics only. We'll encounter this in the beginning of the chapter only. First day, next class only we'll encounter this integration. So do remember this. We'll encounter this in the next class. The next integration is dx by root over a square minus x square. This will encounter in simple harmonic motion. That's like 9th or 10th chapter. So here put x is equal to a sine theta. Then dx will be a cos theta d theta. So when I substitute here, I end up with a cos theta d theta. So the main idea is somehow you have to make it into simpler form. A square minus a square sine square theta. This will become a cos theta. A comes out of the root, and root 1 minus sine square theta is cos theta. Cancels off. You get integral d theta, which is theta. And from here I know sine theta is x by a. So theta is equal to sine inverse x by a. So this result will be sine inverse x by a. So actually, if you can remember the result, that will be also good. But like I said, it will come in 8th or 9th chapter. By that time, you won't remember this. I'll teach you again then. This is the result for this. Max, these are the general formulas. Again, how do you know you have to put this? Again, by kind of observation, like if you know, if I can keep even a cos theta also.
So I need to put something here like, 1 minus sin square theta, 1 minus cos square theta, so that something can pop out. This is the second integration with substitution model. This also will encounter little rare. We'll encounter it 2 or 3 times, because after that we'll just use the standard result. Please check. Any doubts on this? Clear? The last one, dx by a square plus x square. Here put x is equal to a tan theta. This is a x square theta d theta. So this will become a sec square theta d theta by denominator will become a square into 1 plus tan square theta, which is nothing but secant theta. So 1 by a integral d theta. This and this will cancel off. And we know tan theta is x by a. Theta is tan inverse x by a. So this is theta by a. So 1 by a tan inverse x by a. This is your third one. This will start encountering in gravitation, electrostatics, mostly in 12th things, but this will come a little more frequently. That's it. If you know these 3 integration substitutions, you can handle all the integration problems in physics. There are much more varieties, but let maths people deal with that. We will not encounter them. So the 2 new things, the one new thing that you learned is perfect differentials is one, and this integration with substitution, integrating a vector. So if you see today's class is mostly about, it's more of a maths than actual physics we did today. So with this, we are done with calculus. We're done with differentiation and integration. So next class, when we meet on next week, we will start off with kinematics, one-dimensional motion. Okay, so with this, we'll wrap up for the day. We'll discuss the paper cut doubts and any other doubts that you have in the assignments or sheets. So first, we will see any doubts in today's class, and then paper cut doubts, and then assignment cut doubts, and then if you have any own personal doubts, we will see in that way. Any doubts in today's class?